Ballerina is a new programming language that we've been working on for the last 5 years. And it's a language that's designed to address a particular set of problems that are inherent in the way people write applications today. Well, if you look at the way application development has evolved over the last 10, 20, 30 years, if you go back to the 80s and 90s, we had COBOL, we had mainframe era, then we had distributed applications, then we had the web, then we have mobile applications, and now future is going to have some kind of metaverse-like thing and so on. And so the complexity of what an application is has evolved quite a bit. Today's architecture, whether it's a mobile app or a web app or whatever the next kind of device-specific app that you're going to have, involves a front end and a back end of some kind. And the front end, we have very good technology, whether it's a mobile platform or a web platform. And the back end typically is now all a bunch of APIs. So yes, I can write those APIs in any programming language, but if you look at the fundamental problem today that exists, is all about how do I create APIs by taking APIs that exist. So the APIs are now, the capabilities I depend on as well. In other words, the API is the new shared library or the new DLL. And so when I want to write something new for the business, I have to depend on other capabilities that's already in the enterprise. And taking those available APIs and creating a new API is where the game is at now. And of course, I can write that with any language. I can write that in assembly, I can write in C, C++, Python, Java, JavaScript, C#, and so on. But none of those languages actually understand that that is the problem I'm trying to solve. So the purpose of Ballerina is to say, okay, we want to give the developer who's focusing on this problem of creating new APIs, new integrations, new logic, the set of tools that lets them think at the level of abstraction that is natural for the problem. Fundamentally, programming languages are a way of shaping the way somebody thinks, because programming languages are a way of expressing something to the computer so it can run it. So the right level of abstraction has a dramatic impact on how you go about solving the problem. So Ballerina is a new language that says, okay, we have a new problem today, which is best addressed by bringing a new set of abstractions, new set of fundamentals. They obviously build on existing things. We're not talking about some theoretical research language. We're talking about something that's meant to be very practical. So it builds on existing things and yet gives the developer a very clean and clear set of tools with which to focus on when they work on the problem at hand, the new problem at hand. So when we talk about network applications, network interactions, the thing that I can send over the network from one thing to another thing is data. In the 90s, we had the era of distributed objects, where there was a belief that we would have objects that are distributed, and in fact Java had a lot of work done on moving code around. That works for limited scale network applications, things that are running within your very secure environment, but the way in which applications have evolved now and the way the world is evolving, no one will want to share any code over the network like that because it's simply not safe. You can't move code back and forth. So what we move is data. So the data orientation aspect of a language is extremely important. So one of the things that Ballerina is quite strong at, and something we focus very heavily on, is making it easy for you to model the data that the program manipulates and the program sends back and forth over the network in the language, and having a set of very powerful tools in the language for actually writing applications with data and declaring the data, processing the data, querying the data, structuring it, restructuring it, navigating it, all of that stuff. So network is the name of the game today. Every single thing that we do in any business application, any application now always involves a network. So having the right capabilities for the network is for programming the network is very important. Now, the fundamental abstractions for network programming were invented in the 1980s in the BSD socket architecture, and people use that in various forms over years and have created library after library to make it easier. When we were designing Ballerina, we went back to the drawing board on that and tried to understand what are the fundamental primitives of network interactions and how do we create language constructs and language concepts that capture those directly, so that it's easier to program a network application in Ballerina than any other language. So there are several aspects to this. So one is the type system itself. In typical programming languages, there's this concept of data binding. And the concept is that I get some data over the wire, and I need to bind it to a data structure in the language in order to manipulate it. And that itself is a inherent challenge in many languages. We have standards and protocols for defining how I take data that comes over the wire and bind it to the language. So Ballerina was very carefully designed where the data type system, the type system in the programming language, the parts of it related to defining data are all capable of describing not just data in memory, but also data on the wire. And in particular, we've done a lot of work to align that very closely with JSON, as well as XML and various other formats. So that if I have a piece of data that comes over the wire, I can bring it into the language without any artificial, complicated data binding concept. So effectively eliminate the data binding concept for well-known data formats and network data structures. And therefore it makes it very easy because the schema that I write, the type that I write, plays two roles. It describes the shape of values that are in memory, also describes how it shows up on the wire. Right, the same structure, so I don't have this mismatch between the two representations. So once I have data to manipulate, the other part is all network interactions involve services and clients. So I have something that offers some capability and somebody that consumes some capability. So Ballerina has spent a lot of time on the service offering side to come up with concepts of service typing, so we can declare at a very granular language level, this is a network service. This network service has the following characteristics. It has the following structures that we go on that interact with, and so on. And of course, if you try to abstract all network services into a common structure, it becomes a useless abstraction because it's too high level an abstraction. So what we've done is we have a service concept, and then we have specific structures of service concepts for HTTP/REST services, for GraphQL services, for WebSocket services, for gRPC services, messaging services, and so on. Right? So for each one of these, we have a defined set of service types. So when the programmer writes an HTTP REST service, they think in terms of the HTTP protocol. They think in terms of the HTTP paths, the variable path segments, all of that are part of the way you write the function signature. It is not a binding. It is not like a language where it says, well, I have a single single hammer called a function, and I can make it do anything, right? In Ballerina, it is not just a function. We have resource functions, which are the abstraction that we use to support different kinds of network interaction patterns. That's on the service side, and there's a whole lot on this that we can look at in detail. On the client side, that's equally important because every application I write today, when I'm producing a service, I'm always going to consume a bunch of capabilities, a bunch of services. So consuming services also in typical programming language, a service consumption simply becomes a function call. That of course works. Obviously, we're all using programs written like that. But the problem is when I'm looking at the program, I can't see explicitly that this is a network interaction. And as the fallacies of distributed systems show, network interactions are not like local interactions. There's a difference. So in Ballerina, network interactions, when I'm a client, when I'm making an invocation, we have a very specific syntactic approach and a set of semantics that make very clear this is a network interaction. So you, the programmer, have to be aware this is a network interaction and be able to handle it appropriately and handle the different errors and so on correctly, right? So that's a very important part because that allows a developer to think at the level of abstraction for services and the level of abstraction for consumption and wire them together correctly. The other aspect of that we have done very carefully in Ballerina is to be able to model these network interactions when I'm making a network call as a sequence diagram. Now, if I was asked to explain to someone saying, hey, explain to me what happens when I'm integrating a bunch of things, a common way of explaining that behavior is to draw a sequence diagram. Because I can put actors for the different network entities and draw lines and say, I'm going to do this, I'm going to send this over there, that's going to send it over there, and then something happens and then I get a response back and so on. The Ballerina language is designed so that every network interaction can be represented as a sequence diagram. And the sequence diagram's representation is the source code. So that is the sequence diagram representing a network interaction and the source code are one and the same. Right? So these are some of the things that make it very easy for somebody who's writing a network-oriented application to think and operate at the same level of abstraction as what they are familiar with, as what the network offers, and be able to see that in the code. the heritage of Ballerina comes from the world of integration. Ballerina's primary contributor is WSO2, and we have been in the integration space for 15 years, and we've done a lot of work in creating technology for integration. One of the aspects of integration is that the way you write integrations is typically with a DSL of some kind, a domain-specific language, and the reason you do it that way is so you can get a graphical representation of what is going on, and so you can see what's happening. And data flow is a common paradigm for implementing that stuff. In Ballerina, what we have done is we have designed the language so that every program that you write, every single program, not some of it, every single program has a corresponding graphical representation, and the graphical representation is the program. That is, there is no, what I mentioned a little bit ago about network diagrams and how network interactions and how they're represented in sequence diagrams. Every program in Ballerina actually has a flowchart and sequence diagram combination. The work of a single concurrent actor is written in a flowchart. Ballerina is a concurrent programming language, so you can have any number of these things running concurrently, and we have a lightweight thread model called strands to support that. And then the way they interact is represented in a sequence diagram. And this fits very smoothly with how we model network interactions as well. So what that means is every Ballerina program, you can go to the entry point of the Ballerina program and say, generate me a sequence diagram that represents the entire program. And you can see one picture that shows you the full behavior of the program in one diagram. Right? So, there's a saying pictures worth 1,000 words. So the reason we did this is precisely because of that, and because we live in the enterprise space. These applications are written and used over and over again for many years. Enterprise applications, one of the big differences between enterprise application development and sort of hobby application development is that in hobby applications, we write it, we use it, and we forget about it after a while. Typical enterprise apps live on for many years and they evolve. They never usually die. They just keep evolving. And this can go on for 20, 30, 40, 50 years. And we have much of the world still runs on COBOL because that's the reality of how things work. So being able to visualize what the program is doing has a huge impact on the fact that one person writes a code, but that gets maintained and evolved by many, many people over the years. So this visual parity, this text and graphical parity is very important because it's not a case of the picture being something we generate from the code. The picture is the code is the picture. Ballerina is a language that has been designed for writing modern world applications, especially in enterprise scenarios. So why is that important? Why is enterprise somewhat complicated and not just a matter of just saying write the code and you run it? Well, in a meaningful organization, a piece of code gets typically written by one person, and it might get tested in a particular environment, and they might get tested more in another environment, and eventually it goes in front of the users. The access to information that the application is using may not be available for the developer. So configurability is an important aspect of writing code. And of course we've invented all kinds of ways of writing configurations for applications over the years. But the programming language has not been part of that problem before. Ballerina takes the concept of configurability into the language. So configurability basically means any program I write can declare anything as configurable. And what that means is when the program is started up, that input must be given to it. And that allows us to keep the same program and have it very cleanly move from one environment to another environment without having any difficulty in being explicit about what are the dependencies. Because the runtime itself knows I need this stuff, and if it's not given, it will simply not start, right? Or if it's not secure or whatever, it won't start. So it gives a lot of control over the stability of a program to evolve in the lifetime of the program into different environments and manage it correctly. Versioning is another problem. Enterprise applications live for a long time. That means it's not the same version that lived for a long time. People end up evolving it. So dependency versioning, dependency management is a very important part that Ballerina has taken a lot of effort to do the right things. Transactions. While on one side we live in a world where everything can be eventually consistent and so on the other side there are many scenarios where I need to know that, okay, I did this and it actually happened. It got recorded as this happened. So transactions are the fundamental computer science abstraction for that. Ballerina has language constructs for transactions, so that we can add any kind of transaction protocol and support it right into the language. You say this is a transaction, and Ballerina itself will ensure that this transaction is properly executed before it continues on. One of the key things for building resilient applications is how the programmer handles errors. In modern languages, especially in object-oriented languages, the concept of exceptions became very popular. C++, if I remember right, is the one that kind of brought it out to mainstream. It wasn't invented by C++. And then Java adopted it, and exceptions became the way in which you write code. The problem with exceptions is that it gives the developer an easy way out. I don't have to deal with this problem, I just throw it and forget about it. And that results in programs that are less resilient than if the developer has to think about when things go wrong. Because when I write an application, things not happening the way I expect it to happen is normal. So error handling cannot be something that I say, well, it's not my problem, I'm just going to throw my hands up and give up. You have to think about it and decide what you want to do about each and every error situation. And so Ballerina has a different model of error handling, which involves actually having error values which are outside of the normal value space, so that you can always know that this is an error value, and being able to handle them explicitly or hand it over to somebody else. And then there's a lot of detail on that, but this is a very important and complicated problem for application development, so that you can get good quality applications. So we put a lot of effort into giving developers the tools they need in order to handle errors reliably and high quality and with consistency. Concurrency is a modern requirement in any environment, because we now operate in very highly concurrent environments. So Ballerina has a lot of stuff built in for concurrency. There's a concept of workers, strands, that allows a program to be internally concurrent. The program can be invoked multiple times from different people over the network. So there's always, the moment you have concurrency, you have the possibility of race conditions and instability in the program. So Ballerina has a lot of functionality that we've invented, that we've included into the language for concurrency safety. This includes a set of mutability management capabilities around creating read-only data and having access control, so that you can control and mutate values under control. And a bunch of other things that we've done. So concurrency is a very important aspect, again, for building enterprise-grade development, because concurrency is the way of the world. And so if you don't have those built into the language, you're telling the developer use some supporting library or some framework, and as long as they use it correctly, it works, but you have no way of statically verifying that the program is correct. So Ballerina's focus is very much on saying, at compile time, we want to know that this program is correct, and if the compiler says this is good, then it's going to run the way you wrote it, right, with no surprises. And so concurrency safety, error handling, transactions, configurability, versioning, these are all aspects of that makes a Ballerina program an enterprise-grade program. Not just a toy, but something that you can use and run reliably, securely, and safely for a long period of time over multiple environments. Cloud native is obviously a buzzword today, but it also has particular meanings. In particular, it means that when you write a program that you compile and run it, you run into an environment which is inherently adopting all the abstractions and the tools and the capabilities of what we call cloud. In the old days, it used to be that I write a program, I compile it, and I run it on that machine, right, or on a single machine. Today, you write a program, you compile it, and then maybe you'll build a Docker image, maybe you push that to a repository, maybe you put some additional metadata in YAML typically that tells somebody who's deploying that container how to deploy it and how to manage it, and so on. So it's a much more complicated experience that the person has to go through in order to take a piece of code they write and get it to work in the deployment environment of the modern cloud architecture. And that's really what cloud native means. So cloud native aspect of Ballerina is that it makes this straightforward and it brings it to the developer again. So one of the problems in typical development is the development language and the deployment language are two different universes. So Ballerina addresses this and has bindings directly from the abstractions of the language to say, I want to make this into a container, an image, and I want to deploy it, and these are the parameters and so forth, brings them to the developer. So the primary goal there is to make it easier for a developer to be able to write a piece of code and also instruct how it should be deployed in the right environment, right way, in a particular production or whatever environment. And that's what that does is it bridges this gap from development to deployment. We have this word called DevOps. In practical reality, in many cases, dev is one person, ops is another person. So, and to put the two together, you're mixing concerns of capabilities because the tooling that you have to use is so diverse and wide all over the place. So, Ballerina addresses that by saying we are going to give you the ability to write a service, annotate it the appropriate way, and when you compile it, the compiler will generate all the necessary artifacts so that it can be immediately deployed into a cloud environment the way the developer wants it deployed. And obviously with configurability, and all the other aspects of it being enterprise grade, you can also push that out to further downstream decision, because sometimes the developer is not the one who makes the decisions, you push it down further downstream. That's of course supported as well. So Ballerina has a whole bunch of stuff that is interesting and different, but it's also just a programming language. In the end, when it comes down to writing code, I need if statements, I need for loops, I need variables, I need arrays, I need all kinds of stuff. So Ballerina has all of that. Everything that you need, from data structures to the control structures, concurrency control, all of that is in the language. It's a very comprehensive language, and the language includes both a very small library that is part of the language specification itself, as well as a very large standard library, so that you don't need to go to third-party frameworks to do the things that you do 99% of the time. It's all part of the platform. We call that a batteries included platform, which is a modern way of building a language so that you give everything you need in one packaging. So these are not unique. These are standard things that people need, but they inherit the unique capabilities of Ballerina. They inherit the network awareness, they inherit the data orientation, they inherit the concurrency. So they make it easier for a programmer who's familiar with things, the structures from different languages, to come to it, but still taking advantage of what Ballerina is uniquely about. Right? Of course, syntactically also we followed the C family of language syntax, so it's curly braces, the usual kind of stuff. There are some enhancements that we needed to do in order to support the sequence diagram, bidirectional nature, support the concurrency, support the service architecture, and so on. But fundamentally, it's a language syntax that when you see it, you should be able to read the code without any, if you're familiar with anything from the C family, you should read the code without any problem at all. So we have a very strong goal of keeping that familiarity with developers. So we're not trying to be arbitrarily creative in places where you don't need to be creative. We've been creative where you absolutely have to be creative to create the right level of abstraction for developers to think in the network era. So Ballerina is not just a compiler and the language specification. Modern day development involves module reuse, it involves documentation, it involves IDEs, debugging, distributed development, distributed debugging, running in different environments, and so on. So Ballerina is a complete package. We have been working on this platform for 5 years. We have had on average probably 75 engineers working on it right throughout the 5 years. And we have developed not just the language specification and the compiler, but also a very comprehensive tool in the form of a VS Code plugin that lets you write arbitrary Ballerina programs and also simultaneously see the picture, the graphical representation, or edit graphically as well. You can go back and forth. We've developed a set of tooling for dealing with network protocols, network formats. So if you have an open API specification or async API specification or various other GraphQL spec, gRPC, Proto3 spec, and so on, we can generate the necessary code for you. So we've done a lot of work in the overall platform. There is something called Ballerina Central, which is the module sharing facility. So when you have a Ballerina package, which is the unit of distribution in Ballerina, you can build a package, ship it to Central, and then share it with anybody else on the internet. And there are also two implementations that we've done for Ballerina. The first one was written in Java. Ballerina is very important to understand. Ballerina is not a JVM language. It's a language with its own specification, with its own semantics, which as a convenience we implemented first on top of the JVM. So that's called JBallerina. We have another implement, that's the one that you can download right now, the current version. We have another implementation that's in progress that we are calling nBallerina, which is a native Ballerina, which is compiling using LLVM directly onto the platform architectures. So it doesn't go through a JVM layer. So that again makes a point that it's not a JVM language, it's a generic language that can be implemented on any platform. And so this entire set of tools combine to form the Ballerina platform. So Ballerina is a new language. Every time you start something new, some people are the first people to come, some people are the second people to come, and so forth. So when it's something new, there's always a question saying, why should I play around with this? What's in it for me? Why is it interesting? So fundamentally, Ballerina addresses the problem of how do we make applications, modern day applications, in a much more productive way, where the programmer doesn't have to waste time fiddling around with object relational mapping and the data binding problems, the configuration management, environments, all of these things that you have to deal with in development. Ballerina has taken care of for you. It gives you a first-class way of representing network interactions, which no other programming language does to the level that Ballerina has done, where the code is the picture is the code, and you get a lot more abstraction out of it because of that. And it makes the life of the developer so much easier. And we challenge anyone who's writing services in whether it's Node.js or Python or Java or Go or whatever you want to write in right now, take that program, rewrite it in Ballerina, and see what happens. Right? We are very, very confident that it will reduce the amount of effort it takes, the ability to understand the code for a third party who wasn't involved in the code, and the ability to maintain the code and the productivity, the net productivity gain for the developer. Right? So really, Ballerina is a different way of thinking about these problems. And we've been working on this problem for a very long time. Ballerina itself has been underdeveloped for more than 5 years now. And long term, our goal is to create a language that gives developers the level of abstraction and the tooling and the support they need to think at the level they want to operate at for enterprise application development. And none of the other languages do that. So that's why you should try Ballerina.